Hello everybody. In this video we're going to apply what we discussed in the previous two videos on the basics of psychrometric chart and the basic concepts about the humid air in this example. So we have here this psychrometric chart, and we want to calculate the absolute humidity, the wet bulb temperature, and the humid volume. Many things: the dew point, the specific enthalpy of humid air at 41 degrees Celsius, and 10% relative humidity. So as we said before, we need to know two information, and from these two information we can know everything else. So these two information that we have here are the relative humidity, which is 10%, and the temperature. The temperature is not specified, either this is wet bulb or dry bulb temperature. So if it's not specified, then it's the dry bulb temperature. This is the default. So dry bulb temperature of 41 degrees Celsius and the relative humidity of 10%. So as we said, we are going to spot this point on the chart by the knowledge of these two information. So first, the temperature is available on x-axis, so the temperature is 41 degrees Celsius. So it's going to be here. So this is 40, this is 45. It's not clear, but this is 30, 35. So maybe I can zoom in; it would be more helpful. So this is 40 and this is 45. We have 4 ticks in between. So this is 41, 42, 43, 44. So this is 41 degrees Celsius, and the relative humidity are these. This is what's written as the relative humidity. So these are the relative humidity lines. So this is 10% relative humidity, and this is 41 degrees. So the intersection is going to be this point. So the intersection of these two lines is going to be this one. So this point represents the air that we have here, the 10% relative humidity and 41 degrees Celsius dry bulb temperature. So now we can get everything else. So let's go with the requirements. We need to calculate the absolute humidity. So absolute humidity is the moisture content, which is the mass per mass of dry air. So if we go to the right, this is the relative humidity. It's going to be 0.005. Of course, kilojoules, kilogram of water per kilogram dry air. And we have the symbol HA. This is the symbol that we use. So it's as simple as this. The wet bulb temperature. We know that these numbers represent the wet bulb temperature. The number on these numbers on this curved line. So and these numbers are read with this inclined line. So we can go with this inclined line here, and this is what we can or this is the point here represents the wet bulb temperature, which is 15, 16, 17, 18. So it's 19 degrees Celsius. Okay, now for the humid volume, we said the humid volume, these lines represent the humid volume. This line here and the parallel lines to it. This line, these are the humid volume lines. So the humid volume would be, there is no line that passes by this as a humid volume, but we know it is between 0.85 and 0.9 meter cubes per kilogram dry air, and it's very close to 0.9. You can do some calculations if you measure the distance between this point and the 0.9 line, and the distance between this point and the 0.85 line. From the ratio of the distances, you can know the exact number, but it's going to be around 0.9. It's going to be, if you see this is 0.85 and this is 0.9, so this is going to be around 0.895 or something. So it's going to be around almost 0.9. This is what is written in the textbook. And for the specific enthalpy, the enthalpy is read from the same line here. So if you see the enthalpy, it's going to be, this is 51. Let's zoom in. This is 51, 52, 53. So it's 54 kilojoules per kilogram dry air, but this is for water, the air saturated with water. This air is not saturated with water, so we need to have the correction factor. So the correction factor is, or the deviation as it's called here, the enthalpy deviation. So it's between negative 0.6 and negative 0.8. It's more closer than to negative 0.8, so I'm taking it as negative 0.75. And one thing to notice that this chart is not very accurate, so you will get approximate values for the results. So I can put it 0.75, you can put it 0.78, 0.79. It's up to you. It's based on your estimation. You can do this in a more accurate way, but yeah, the difference is not going to be that much. So the difference is going to be for 54.5, which is this point here. I said 54, but I think it's more 54.5, and it's something in between. And again, these are all not very accurate results. This is the nature of charts. So the result is going to be 53.75 kilojoules per kilogram dry air. We're done with the humid volume and the dew point. So the dew point is, as we said before, the dew point is the temperature at which the air would be saturated. So if I take this air with the same conditions, and I reduce its temperature, the relative humidity increases because the saturation pressure decreases, and it keeps increasing until it reaches 100%. So by decreasing temperature, the moisture content is not changed because it's mass per mass, so the mass is not dependent on the temperature. So we are decreasing the temperature, so we are keeping the moisture content constant, and we are going to the left in a horizontal line. So if you go all the way until you reach this line where it's called the saturation temperature, where air is saturated, or this is 100% humidity. So this gives us the dew point of 123 degrees Celsius, which is the dew point. So this is all got by just the knowledge of two information from the chart, which is very, very interesting, that you can get all this information from just using the chart, which is not a complex chart, by the way. There are many charts that are much more complex than this. So there is other requirement here to determine the amount of water in 150 meter cubes of air at this condition. And if I have 150 meter cubes of air, how much water will be in there? So the volume is 150 meter cubes. But this is volume, it's not the volume of dry air. And this is something to notice, that this is the volume of the air with the humidity or with water vapor in it. And keep in mind that this is the moisture content as the mass per mass of dry air. The volume is volume per mass of dry air. The enthalpy is per kilogram of dry air. So this is something that is important to notice. So and what you would think is that you would say, okay, I know the moisture content, which is the mass per mass of dry air. I know the humid volume, which is meter cubes per kilogram of dry air. So if I multiply, if I divide, or given the information, and we'll talk about the division or multiplication later. Given the information of the volume per mass of dry air, if I know the mass of dry air, I can get I can get somehow the mass of the water in the dry air by knowing this volume, by knowing the humid volume, and by knowing the moisture content. It's going to be just adjustment of units. So the first thing is to know the mass of dry air, because this is what everything is measured according to. So to get the mass of dry air, we can use the information that we have. I know that this is the humid volume, which is 0.9 meter cubes per kilogram dry air. What we did here is we multiplied the total volume, and again, this is what we have here as the total volume. It's not the mass of dry air, it is the total mass. So the total volume, the volume of dry air per mass, the total volume over the mass of dry air. Again, this is the total volume over the mass of dry air. So and this is the total volume. So if I want to get the total mass of dry air, I can multiply the volume by 1 over the humid volume. So it's exactly what we did when we multiply the volume over the specific volume to get the mass. So it's the same thing. So this is 150 meter cube divided by 0.9 meter cubes per kilogram dry air. So the multiplication of these two terms is going to give us the mass of dry air that we have. So I know the mass of dry air, but this is not what I'm looking for. I'm looking for the mass of water, or the amount of water, which is a mass of water. So to get the mass of water, we can use the moisture content, which is the mass of water per mass of dry air. I know now the mass of the dry air, so I can know the mass of water in this dry air. So by multiplying these two, we know the mass of dry air. By multiplying everything, we know the mass of water only, not the mass of the whole mixture. So it gives us the mass of water, and that's it. So this is all for this problem. So I'll stop here, and next time we'll solve another problem which is a bit more detailed than this. So I'll see you next time, inshallah. Goodbye.